The OFP, or Open Filament Program, is a collaboration between Raise3D and filament manufacturers, so we can give you the widest range of filaments for use in our Raise3D printer. Contact sales at raise3d.com for more information.
Welcome to another Raise3D live stream. As always, my name is Nick. I'm in the demo studio. I'm joined by Buzz Baldwin from 3D PrintLife. How you doing, Buzz?
Great. How you doing?
I'm doing fantastic. Pleasure to have you. So you're with 3D PrintLife. You please give me a rundown on just what that is, how we work with you, what you guys do, get me up to speed.
Yeah, no, absolutely. So we're a filament manufacturer. We have our own line of materials that are geared towards the sustainability, eco-friendly vein. And we're a reseller of 3D printers, including, of course, the Raise3D line, which we are huge fans of because of the quality and everything else involved. And that is us in a super nutshell.
So you mentioned like sustainability. What are the things that you're focusing in on the specific materials? What are the highlights of your guys'?
That essentially the bioadditive technology we're using essentially provides a food source for bacteria once these materials end up in the waste stream. So it doesn't alter the material characteristics. So your PETG parts, your ABS parts will still perform that way. They won't start to degrade on your countertop or in your end-use parts, whether it's in a machine or whatever sort of your application is. Really, once they get into the waste stream, that's where you see the benefit of the bioadditive component that allows bacteria to consume it and eventually degrade it over time.
What makes yours unique in that waste stream breakdown?
Great question. And so an active landfill is not just an entombed landfill where, a banana peel might take decades to degrade. This environment is truly one of the nastiest environments on Earth. You have a high bacteria content that is designed to consume material that goes into the landfill and convert the carbon in those base materials into CO2 and create landfill gases like CO2 and methane. And the way landfill to energy facilities work is they collect that methane and either collect it for storage to use later, or they quickly refine it and burn it to create electricity, hence landfill to energy. The standard for PLA is the testing involved. It's ASTM D6400. This governs biodegradability of plastics. Now, the way our plastics work, the way the filaments work, is once they enter into this environment, into this waste stream, the bacteria in that environment begins to consume the plastic. And it's really our bioadditive that just provides a constant food source for the organisms in these facilities. And here we have a nice comparison showing standard, petroleum-based plastics like ABS or PETG in the red line here, and CO2 production based on those materials. And then the green line would be steady CO2 production with a plastic that's containing our bioadditive. One of the questions we get asked a lot is, how long is it going to take my parts to degrade? And it's a really tough question to answer. Every facility is different. The bacteria contents are different, even within a facility, within a vat of, within this sort of leachate bacteria system. I always say that, if your part starts degrading on your kitchen countertop, you've got much bigger problems than your part losing integrity, for sure.
Because it is a specific type of bacteria that's meant to feed on the extra elements in that material and then break it down. The breaking down shouldn't happen until it's in the waste environment, essentially.
Exactly. And so really we get the benefits of the strength, all the mechanical properties of whatever base material we've combined the additive with, and you don't lose that. So you can feel secure that your parts are going to work long term, but things like, failed prints, support material, or when your part reaches end of life, you've got that extra peace of mind that once it gets into the waste stream, you do have that added eco benefit, and your part's not going to sit there for hundreds of years, depending on the facility it ends up in. And so that covers really sort of that range of plastics. The rest are really more, again, sort of in that PLA blend range. I mentioned the algae material, so happy to jump into that one.
Yeah, please do.
And so this is a PLA with a little bit of a bioplastic modifier to help sort of stabilize the material and make it easier to 3D print. But we've taken this nuisance algae that's been removed from the environment from waterways, ponds and waterways, where it's causing damage to marine life or aquatic life, and so it's being removed from there using sort of a skimming process and these micro air bubbles that actually reintroduce some oxygen back into the system. So before this filament even gets on your printer, there's an eco benefit happening, which is great. But we've also got this really cool, these are standard PLA colors, and we end up getting this really nice color palette that's very earthy. The material itself has a feel of like sandstone or wood, but this is the natural color here, without any color added. And there's obviously going to be a lot of variance. I mean, you can see it's a natural material here. I really love it. It's one of our more popular materials for sure. We reformulated just to make it more stable for 3D print and just sort of remove some of the brittleness of it and increase its lifespan. So our replay, this is a recycled PLA filament. One of the questions we get asked a lot, being a manufacturer that's focused on sustainability, we get a lot of offers from customers and just the general public to have them send us their scrap filament for recycling. There's really just no feasible way to do it because we just don't know what we're actually getting when it comes in. And if you try to sort of grind that up and recycle it and extrude it, you end up with a really nasty polymer that doesn't perform well or extrude well, and it's just not worth the headache, unfortunately. So what we've done here is we've created a recycled PLA that is strictly made upcycled from production scrap. So any PLA we're making that is out of spec, when we're changing diameters or changing colors, this is what ends up sourcing this material. But it's really stable, it prints really well, and it's priced pretty reasonably. So that's Replay. Our Pro PLA, it's PLA with a little bit of a bioplastic modifier to increase strength, increase pliability and lifespan a little bit, better impact strength. Not a major, I wouldn't call it a tough PLA or anything. It's just a, impact modified PLA. Now our PlayFab, on the other hand, is a different story. So this is really a tough PLA in our minds. So this material, it's a PHA blend, not unique to the 3D print space, but it adds a lot of impact strength, a lot of pliability, massive upgrade in shelf life. Some universities have used this exclusively, have left spools out on the shelf for 18 months and put it back on the printer, after it's been exposed, and it prints like it was just taken out of the box. So you don't see that sort of normal PLA degradation because of exposure, which is great. And same with our Yoga Flex. This is a flexible, biodegradable material that is made from some kind of funky, it's a funky blend of materials, but it's a really nice, strong, semi-flexible material. It's really permissive to print with. Omni is really meant to be an ABS mimic. It's a PLA base with some other bioplastics involved that make it really rigid and strong like an ABS, but you still have that biodegradable component. So it falls under the same standard that PLA does. And Dura is a nylon mimic. So this material has a little more pliability to it, but it'll really take a nice impact strength. A lot of drone guys are using this because it'll take an impact where it won't, because it's not rigid, it won't shatter, but also prints at a really low temp. There's a minor sustainability benefit, but one of the things that we factor into sustainability is quality of the hardware. So when you have features like auto bed leveling, filament runout sensors, all these things that sort of go into reducing failed prints, that is another way to improve sustainability in 3D print, because obviously less failed parts means less wasted material, less energy consumed. It all sort of factors in under the same umbrella for us. So anything you can sort of do to whittle away the variables that can cause a failed print is going to improve sustainability from there.
I like the uniqueness that you have for your guys' specific materials, things like the Omni and the Dura, how it is intentionally specifically designed from the get-go to work for lower heats, lower temperatures, just using less energy overall from essentially start to finish, where the materials come from, how they're being printed, how they're being, kind of degraded afterwards. The entire life cycle of the material from start to finish is always being kind of consciously brought around and prioritized for what you guys are doing for your materials. And I think that's fantastic.
No, thank you. And of course, I sort of forgot to mention the obvious that you can see there in the images was the spooling we use is cardboard spooling, so we're not using plastics there, which actually can come in handy because some of the plastic spools, if they're being heated to a high temp, can warp a little bit. So there's metal end caps. I actually have one here, right? So here's a blank spool. So these are just loose metal end caps. They're made of tin that they use to assemble the entire spool together in one shot. This thing is really strong though. It's really hard to get apart, so we don't lose any integrity of the spooling with the outward pressure that happens when you're winding the filament on. We are looking to migrate to a fully glued spool. We've got a high temp glue that'll work. We're just sort of dialing that in just to sort of remove the end cap. The end caps themselves they're not a pain or anything. I actually enjoy them. They're strong, they're really durable, but it's an added sort of labor component. It's definitely more of an expense, and cardboard, everything's been going up in price over the past year. So anything we can do to sort of minimize that is going to be, we don't want to raise our prices on our filament because our spool components are getting more expensive. But I mean, the whole point of 3D print is just removing limitations, giving more opportunity for, home users, innovators to create something on their own without using traditional fab that takes a lot of time and money to achieve. You can do so much with a 3D printer and the right material to sort of realize your vision.
Yeah, so working with things like Pro 2s, Pro 3s, it's all about the variety of materials you can use and expanding the options of what you can do with not only just, designing parts and manufacturing in general, but with these specific machines, things like Idea Maker, Cloud Remote Operation. A lot of things that we prioritize are just opening up those other options, including things like Open Filament Program, partnering with you guys and other manufacturers, just opening up the space, making it easier to work in and get more out of these machines, make them greater than the sum of the parts, essentially. But
exactly, and it should be. And I love the Open Filament Program. I mean, that even that in itself. I mean, just sort of a small nod to sustainability. I mean, just having the print profiles loaded already for you in that program, just reduces sort of lead time of dialing in a material. You're just sort of, off to the races the moment you get the spool on the printer. Yep. But definitely, I mean, look, we love the Raise3D line. I'm dying to get a Pro 3 myself. I'm jealous every time we ship one out the door and I don't have one for myself. But I mean, that whole platform, I know it's been upgraded from the Pro 2, but that whole platform certainly does improve print quality, definitely reduces failure rate, which, from a sustainability standpoint is great, but just from, a functional high-end prosumer FDM 3D printer is fantastic.
Coming up on time, but did you have any kind of last things to wrap up on? Anything new coming out from 3D PrintLife?
Yeah, we're actually, thank you for asking. We are working on a couple of new materials. One will be a PETG that's made from post-industrial recycled materials. So your plastic drinking bottles, right? So Arrowhead out there, Poland Spring out here, recycled bottles combined with our bio additive. And then another one that I'm really hoping to get launched in June or July is really a game changer for us, and I'm hoping for the industry as a whole. It's a filament made from a certified marine and home compostable material. First of its kind. I'm really excited to get it out on the market. We're still sort of working on completing some internal testing here. Everything right now looks really good. I'm not sure what the price point's going to be like yet, but to have a material that is truly home compostable or made from that material, home compostable, marine compostable, will be a game changer for us. And we certainly don't recommend tossing in parts in the ocean. Let's be clear. But we do get a lot of requests from people that are working in the marine environment. Whether it's things like NOAA or people that are just like sort of scuba divers that are making parts that could accidentally end up in the marine world. It's a great benefit there.
And so I'm looking forward to having that new material soon. Looking forward to a lot of new things you guys are coming out with. Again, we're always working on our new machines as well. I think it's going to do it for us today, Buzz. Thank you very much for joining me.
No, thank you. Yeah, it was my pleasure. A lot of fun. Thank you.
Of course, it's great to have you. But I think that's going to do it for us today. I'm going to go ahead and wrap it up, and I will see everyone in the next stream.